Hi, this lesson is on understanding what real zeros of a polynomial function are. So somebody asks you to find the real zeros of a polynomial function. What is that you're trying to find? A real zero of any function, that's not just polynomial function, is a real value of x where the value of the function is going to be 0. So if you take a value of x and substitute it into your function and get 0, then that value of x is called a real zero, if it's a real number, of course. Graphically, it's the point where the graph is going to cross the x-axis. We also know those points as the x-intercepts of the function. So when you apply it to polynomial functions, that's exactly what you're going to be looking for. I'm going to start with this very easy example. This is the graph of some function that's a polynomial function. We're trying to find its real zeros. So what we're going to look for are the points where the graph crosses the x-axis, the x-intercepts. So we see it happening at -3, we see it happening at 2, and we see it happening at 5. Those are our real zeros. By the way, because it touches like this here or crosses like that does not make any difference. It still comes into contact with the x-axis. So real zeros here are going to be those 3 points, -3, 2, and 5. By the way, you can write those numbers in any order you want, does not make any difference. Okay, so that's how it works with the graph. Then we have these types of problems, this is when a function is given to in factored form, which is actually very nice. You may remember doing that with quadratic functions when you have factored form, and basically trying to find the real zeros of that. So we're just going to set it equal to 0. That's what it says here, and we solve it. And because it's already broken down into factors, you set each factor equal 0, which basically means x minus 1 is going to equal 0, or x plus 2 is going to equal 0, or 2x plus 1 is going to equal 0. So you solve each one of these equations. They're very simple equations. This one's going to give you x equals 1. This one's going to give you x equals -2. And this last one is going to give you x equals -1/2. So our real zeros will be 1, 2, and -1/2. Remember, the order in which you are going to write them does not make any difference. Let's connect it to what we just did. What if you do it graphically? So if you take this function that you have there and type it in the calculator, you can get the following graph, and I'm going to show you that in a moment. Let me just put it in. So what you do is you type it in just the way you see it. You can put it in factored form, doesn't have to be anything fancy. And then we graph, and this is going to be the graph of our function, and we can see that our intersection points appear to be, this is -2, this is about -1/2, and this is 1. Okay. And you can of course check that by going into the table of values, for example, and see to make sure that, for example, we have 0 at 1, we have 0 at -2, and somewhere over here between 0 and -1 you have another value. Okay, so let's move on. Our next problem. X plus 1 times 3x minus 2 times x minus 1 squared. This square is irrelevant as far as when it comes to finding real zeros. It does have a meaning, but we're not going to discuss that in this lesson. So, but if you want to write it with a square, that's okay. X plus 1 equals 0, 3x minus 2 equals 0, or x minus 1 squared equals 0. We know if something is squared and equals 0, that means the quantity that you're squaring is going to equal 0, which means that's going to give you x equals 1. This here gives you x equals 2/3, and this one gives you x equals -1. So our real zeros here are -1, 2/3, and 1. And if you want to do it graphically, you can. You take your graphing calculator, put your function into it, and after that you will press the graph, and then you will have your graph ready. Let me just put it in real quick. I got a graph, and let me check here, I think, just to make sure I put it in correctly. Yeah, this is where graphing method is not very perfect, because if you look at this graph, you don't really see it crossing the x-axis 3 times. So over here, you're going to see 2 intersections. And when you ever see points like this where you can't clearly tell, you always want to go there and zoom to make sure that, so if I go to zoom in and go near that point and press enter, I'm still not sure what's going on there. I'm probably going to zoom again. If you know a little bit about the behavior of polynomial functions, you should understand this is probably okay. So here is, you see that it goes up, then down, then up again. So it does have 2 different, there is 1 intersection here and there is 1 intersection here. All right. Next example, same work. Note that it's x squared minus 4 here, which is okay. That means we're going to have 1 quadratic equation. So what we want here is x plus 1 to equal 0, or x minus 3 to equal 0, or x squared minus 4 to equal 0. These 2 are very easy. They're linear equations. This here you can solve by factoring if you want. It's x minus 2 times x plus 2 equals 0, which gives you x equals 2 and x equals negative 2. And we have 4 points here, negative 1, 3, 2, and negative 2, right? While you're taking care of that, I will set my function into the calculator. Plus 1 minus 3 is x squared minus 4. And the graph, I'm going to show you this graph in a moment, and hold on. X plus 1 times x minus 3. Okay, here we go. Here's going to be our graph. So we can clearly see it crosses at 4 points, and we can estimate them. And again, you don't want to rely on the graph alone. You always want to verify it by using maybe a table of values or numerically by substituting that. But if you go to table of values here, sorry, where is it? Table. If you go to table of values here, you can see that it's 0 at negative 1, 0 at 2, 0 at negative 2, and that's how you can do it. Okay. So same thing with this problem. We're going to set each of the factors equal 0. We're going to do 2x minus 1 equals 0, have x plus 3 equals 0, or x squared plus 4 equals 0. I want to underline the word real here. I will explain to you why I'm making a point about that. X equals 1/2, x equals negative 3. This is something that sometimes students try to figure out, and they come up with some ingenious answers. It's not actually correct. This equation here does not have real solution, because, for example, if you write it as x squared equals negative 4, then you have a square here equals a negative number. That means it does have solutions, but they're not real. So you have no real solutions here. Okay? So does it have solutions? Yes, you can find 2 more solutions. They will not be real. We're trying to find real solutions here. That means we are going to only write those 2 numbers. 1/2 and negative 3. So non-real 0 is not going to show as an intersection on the graph of the function. So let me go ahead and graph this function. X plus 3 times x squared plus 4. Because remember, we're looking for the intersection of the graph with the x-axis. So this is what it's going to look like. You only have 2 points of intersection. Again, as I showed you earlier, that's not a guarantee. You may want to check this, but if you actually zoom in, you will see that it's only going to cross the x-axis here at negative 3 and here at 1/2, and that's it. and the other 2 points, the other solutions, they are not going to be real. Okay, so what about a situation when it's not factored and it doesn't have an easy way of doing that? So then you can do that by graphing the function as is given to us, and finding the real zero by relying on, in this case, on zero feature. So if I go to y equals and put my function in, so I have x cubed minus 5x plus 1, and I graph it, I'm going to get the graph that looks like this. So we see clearly that it crosses the x-axis 3 times. By the way, the degree here is going to tell you the most number of zeros you're going to get. So if we have a cubic function with degree 3, that's what it means, we can only have 3 solutions, so we don't need to look for any more. So what we're going to do here is we can identify clear values. It's just something here between -3 and -2, something between 0 and 1, and something it's very hard to tell. So what we're going to do is we're going to hit a calculator mode, and we're going to go to 0, and then we're going to set the left bound. So we can do this. Just move the cursor. So we need to be to the left of our point here. And then we're going to go to the right of our point and guess. So our first value is going to be -2.330 if I round it to the nearest thousand. So -2.330. Then to find our next real zero, we're going to do the same thing. Second calc, option 2, then go to the left of that point somewhere here. Go to the right of that point somewhere here, and our next point is going to be 0.202, and we're going to do it again for the third point, 0, and we are going to get 2.128. Okay. So graphically it can be done too, and then of course the precision will depend on what you are looking for. The more precision you need, the more decimal places you're going to keep. And that's how it can be done. I hope this helps.